All right, so number 7, which is the very first problem on page 5, says in the diagram, triangle ABC is congruent to triangle EDC. One of the things I want to point out, because there was a little bit of confusion, not a lot, but a little bit of confusion on the activity that I left for you yesterday. This is a triangle congruence statement. If I ask for you to write me a statement showing that the two triangles are congruent, this is what I'm wanting. I'm wanting something with that triangle shape at the beginning, and then the 3 vertices congruent to triangle shape at the beginning, 3 vertices, and making sure to match up the corresponding congruent parts. So the first 4 problems on the activity from yesterday, I wanted you to write statements like this. All right, so let's go through and start matching up the corresponding congruent parts. First letter in the first triangle name is A. What does that correspond to in the other triangle? E. So that means that angles A and E are congruent. And when I look at my picture, they're already marked with something. What do the markings mean that are here at A and E? Right angles. They're both marked as right angles already, so I don't need to put additional congruence markings in them because they're already marked with their sizes and with their congruences. All right, so that was first letter, first letter. Give me another pair of corresponding congruent angles. B and D, yes. Angle B and angle D. So angle B is over here, and angle D is down here. And then what would another pair of corresponding congruent angles be? C and C. Or if I wanted to be really clear about it, the angle in the top triangle is ACB, and the angle in the bottom triangle would be DCE. So it's talking about these vertical angles here. This angle is congruent to this angle. Then we still need to go in and mark up the corresponding congruent sides. This is like the second set of 4 problems that you had on the activity yesterday. I wanted you to mark up the corresponding congruent angles, but to also mark up the corresponding congruent sides. So we look at 2 letters at a time for that. The first 2 letters in the first triangle name is AB. What does that correspond to on the other triangle? ED, first 2 letters, first 2 letters. So AB, which is the top, is congruent to ED, which is the bottom. Then I can look at the last 2 letters, BC. What would that correspond to? DC, last 2 letters, last 2 letters. So BC, this one over here, is congruent to DC, this one right here. And then we still have a third side. We still need to mark up that third side. What are the other, or what is the last pair of corresponding congruent sides? AC and CE, this one right here. The first and last letter, AC, and the first and last letter here, EC. So AC and EC, like this. Whenever you are given a triangle congruent statement, the very first thing you do is completely mark up those 2 triangles. All right, we need to find X and Y. The only place that I see X is up here along segment AB. And we've marked up that segment AB is congruent to what other segment? DE, right down here. So we know that segment AB is congruent to segment ED. That means the length of segment AB is equal to the length of segment ED. How big is segment AB? (3x minus 10). How big is segment ED? 20 yards. So I have 3x minus 10 equals 20. Then we're going to solve this for x by first adding 10 to both sides. So I get 3x equals 30. And then I divide both sides by 3. And that means x is how big? X is 10. All right, we found x. We still need to find y. The only place that I see y is right here, this angle. When I look at this top triangle, do I know how big the other two angles are? What do you say? Yes, I do. I know that angle A is how big? Angle A is 90 degrees. Angle B has a congruence marking on it, but no picture, no 38 degrees. There we go. It's congruent to angle D. I didn't have an angle marking up here, but I did here. So I know that angle B is 38 degrees. So I know two of the angles in the triangle. I'm looking for the third one. What can I do? Yes, we're going to add them all together and equal them to 180. So the measure of angle A plus the measure of angle B plus the measure of angle. I can't call this one C because that's not clear whether I'm talking about the top or the bottom angle, but I can call it ACB, and that's equal to 180. In the place of A, we're going to put 90 degrees. In the place of B, we're going to put 38 degrees. In the place of ACB, I'm going to put Y, and then that's equal to 180. So then we combine our like terms together. What do I get when I combine 90 and 38 together? 128 plus Y equals 180. And then I subtract 128 from both sides. And what do we get for Y? 52. So Y is 52 degrees. Nicely done. Very nicely done. All right. Let's look down at the next piece on the page, which is actually a new theorem that we're going to talk about called the third angles theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. So what this says is if I know that angle C and angle K are congruent, those are marked right here, and I know that angle B is congruent to angle J, that's marked right here, then that means that angle A and angle L have to be congruent. So this angle and this angle must be congruent because the other two pairs of angles are congruent. Or to write this down another way, if I know the measure of angle A plus the measure of angle B plus the measure of angle C, those are the three angles inside my first triangle, so I know those would add up to 180. In the other triangle, I can say angle L plus angle J plus angle K also equals 180, because that's the three angles inside the triangle. We're told up above that C and K are the same. They are congruent. We know from up above that B and J are the same. They are congruent. And we know that it comes out to be 180 and 180, which is also the same. So if this is the same, and this is the same, and this is the same, then it has to be true that A and L have to be the same. These must be the same. Must be congruent. All right, so I want to practice with that. Let's look down at problem number 8. We're going to look down at problem number 8. Aika is folding origami dragons for a party she is hosting. Triangle ABD is congruent to triangle CBD. Triangle ABD is congruent to triangle CBD. The measure of angle BAD is 58 degrees. Find the measure of angle CBD. Well, the first thing I want to do is use my triangle congruence statement to mark my triangles all up. There is something that I noticed, and I don't know how well it printed on your page, but what do you guys see right here? Right angles. So I'm going to go ahead and darken those in so it's easier for me to see. Those are already marked as being congruent right there. According to the triangle congruence statement, we know that angle A is congruent to angle what? C. Angle A is congruent to angle C. What other angles would also have to be congruent? So I can't just call this angle B, because there's two angles down there. I got to be more specific than that. What would I call the one on the left? ABD would be this angle right here, this left half. What would we call the right-hand one? CBD. Those are congruent. And then we can mark our sides with congruences. Side AB would be congruent to what? CB. AB is congruent to CB. First two letters, first two letters. Give me another pair of corresponding congruent sides. BD and BD. BD is congruent to itself. What else? AD and CD. First and last letter, first and last letter. All right, so let's add in now the information they gave us. It said the measure of angle BAD is 58 degrees. Well, here's B, here's A, here's D. So this is angle BAD right here. It says it's 58 degrees. We want to find the measurement of angle CBD. Angle CBD, C down to B and up to D. So we're looking for this angle right here. This is the one we want to find. What other angle do I already know up here? C. How big is angle C? 58. It's the same as angle A. So I can put in 58 degrees here. then how would I go about finding this angle down here, CBD? Yes, we are going to add the measure of angle C plus the measure of angle CDB. Angle CDB is this one right here, plus the measure of angle CBD. We're going to set that equal to 180. In the place of angle C, we're going to put 58 degrees. In the place of CDB, we're going to put 90 degrees plus angle CBD. Equal that to 180. Combine my like terms together. What do I get when I combine 90 and 58 together? 148. So I have 148 plus the measure of angle CBD, and that's equal to 180. Then I subtract 148 from both sides. How big is CBD? 32 degrees. The measurement of angle CBD is 32 degrees. Nicely done. All right, let's look down at number 9, the last one on this page. The kite shown is made of 2 congruent triangles, but it didn't give me a triangle congruent statement this time. It just said it was made up of 2 congruent triangles. Let's see if we can figure out which angles are congruent. It tells me right here about 2 such angles. Angle BAD is this angle right here, and angle BCD is this angle over here. And it says they're both how big? 45. So I'm going to mark this angle as 45 degrees. And I'm going to mark this angle as 45 degrees. How big would this angle be right here? 90. It's a linear pair with this one right here. So they have to both be 90 because the one side is 90 and they form a linear pair. So I can mark that as 90. So what does that mean about my 2 little angles up here? They are also congruent. That's that third angles theorem. So I'm going to mark them as congruent. We want to find the measurement of angle ABD. So we are looking for this one right here. What can I do to find that angle? Yep, 45 plus 90 plus that angle, and then set it equal to 180. Yes. All right, so we're going to say the measurement of angle A plus the measurement of angle BDA plus the measurement of angle ABD is equal to 180. In the place of angle A, we're going to put 45 degrees. In the place of BDA, we're going to put 90 degrees. Plus the measurement of angle ABD equals 180. What do we get when we combine 45 and 90? 135 plus the measurement of angle ABD is equal to 180. And then we minus 135 from both sides. So how big is ABD? 45. Nicely done. Okay, so that finishes out everything that we were going to talk about CPCTC so that you can do the homework that's due tomorrow. We're going to go ahead and flip the page and talk about some isosceles triangles. Isosceles triangle theorem. The isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Those are called my base angles. So I'm going to sketch a real quick picture of what I mean. Right up here. If I have two sides that are congruent, like these two sides here, then the angles that are opposite those sides, so that would mean this angle here, and opposite would be this angle here. Those angles are congruent. These angles here would be called my base angles. It's not always going to be the bottom two angles. I could take this triangle and turn it on its side. These would still be my base angles, even though they would be rotated and not on the bottom anymore. You're looking for the two sides that are opposite, the two angles that are opposite the congruent sides. I'm sorry, dear. The isosceles triangle theorem says if two angles, isosceles triangle theorem converse, my bad. If two angles of a triangle are congruent, those would be my base angles. Then the sides opposite those angles are congruent. So let's draw another picture. There's my triangle. If my base angles are congruent, in this case, this would be a base angle, and this would be a base angle. If my base angles are congruent, then the sides that are opposite those base angles are also congruent. All right. Let's see if we can solve a problem. See if we can solve a problem. Number 2 says to find x and y. So I have a problem when it comes to finding x because I see an x here, here, and here. But I don't know if any of those sides are the same size. And we don't have any rules about what the sides of an angle add up to. We have a rule about what the angles of a triangle add up to, but not what the sides of a triangle add up to. So until I know which sides are the same size, I'm not going to be able to find y or find x. So let's move on and see if we can find y, and then see if we can use that to find x. Y is right here, which is an angle. What other angles do we know? 28 and 104. 104 is on the outside. What do we call angles that are on the outside? Exterior angles, yes. There's an exterior angle. So what would we call these two that are inside the triangle but don't touch that exterior angle? Yes. Close. Close. They are interior. They're not alternate, though. Looking for a word that starts with an R. Remote interior. These are remote interior angles. This is that theorem that we learned back at the beginning of this module, and I said I'm a little worried about us remembering this one. This exterior angle theorem is the one that's kind of hard for us to hang on to. But the rule about this is that if I have two angles inside of a triangle that do not touch my outside angle, I add those two inside angles together, and it will equal my outside angle. This is the exterior angles theorem. Exterior angles theorem says I'm going to take y plus 28, set it equal to 104, my exterior angle. So then I subtract 28 from both sides. And that means y is how big? 76. So y is 76. I'm going to add that to my picture. This is 76 degrees. Do I have enough information to figure out how big this angle is right here? Can I find this angle? Yes. I can either add these two together and minus it from 180, or what do we call this special angle pair? Linear pair. Those add to 180. So I could do 180 minus 104. Let's go ahead and do that. These two angles right here are a linear pair. So I do 180 minus 104. What is 180 minus 104? 76. So this angle right here is 76 degrees. That's interesting. Why do I find that intriguing? Yes, because y was also 76. So this angle here is the same size as this angle here. That means this is an isosceles triangle. I have two angles that are the same size. The isosceles triangle theorem converse that we just wrote down a moment ago says if I have two angles that are the same size, then the sides that are opposite those angles are also the same size. So opposite this angle up here, what side is opposite that angle? What side is opposite y? Yes, 8x minus 18. This side right here. going to go ahead and mark that with congruences. What's the other side that would be one of my congruent sides? Yes, opposite this would be 6x minus 2. So we are going to use the isosceles triangle theorem converse. And that allows me to take 8x minus 18 and set it equal to 6x minus 2. Now we're going to solve this for x, so I'm going to get my x's to the same side first. I'm going to minus 6x from both sides. That gives me 2x minus 18 equals negative 2. Don't forget to bring that negative down. Then I add 18 to both sides. What is negative 2 plus 18? 16. So 2x equals 16. Divide both sides by 2. And that means x is 8. All right, let's see if we can do number 3 and call it a day. Let's see if we can do number 3 and call it a day. All right. We are supposed to find the measurements for all of these angles over here. Let's see if we can use the picture to fill in some pieces, and then we'll go over and answer the questions about the angles. I noticed that this side and this side are marked as congruent. That means that this triangle right here is an isosceles triangle. It has two sides that are the same size. If it has two sides that are the same, then it has two angles that are the same. And the way I find the angles that are the same is because they are opposite those congruent sides. So here's one of my congruent sides. Here's the angle that it is across from. So where's the other angle that would be 54 degrees? B? So I'm looking for angles. BC is my other side that is congruent, yes. So I'm looking at that. How do I find the angle? Yes, BDC. Here's the side, the other side that's congruent. Here's the angle that is opposite that. So this would be congruent to this guy up here. So that means this angle right here is 54 degrees. Do I have enough information now to find angle C? Yes. What could I do to find angle C? Yes, we're going to do 54 degrees plus 54 degrees plus the measurement of angle C. Set that equal to 180. When I combine my like terms here, 54 and 54 is 108. Plus the measure of angle C equals 180. Then I subtract 108 from both sides. What is 180 minus 108? 72. So the measure of angle C is 72 degrees. I'm going to add that to my picture. Nicely done. I don't know any of the angles on this left-hand triangle. But I do have a special name for this angle pair here. Linear pair. What do we know about a linear pair? They equal to 180. So I can do 180 minus 54. What is 180 minus 54? 126. So this angle here is 126 degrees. I know because of these two markings right here that two of the sides of this triangle are congruent. That means this triangle over here is also an isosceles triangle. Would this be one of the two congruent angles for this triangle? Is it opposite my two congruent sides? No, it touches my two congruent sides. I want the angles that are opposite those two congruent sides. So one of those angles would be this one down here. And the other angle would be this one up here. Congruent means what? Yes, equivalent means same size. So these two are the same size. I don't know how big either one is, but I know they're the same size. And I know the three angles in that triangle add up to how much? 180. So since I don't know how big those other two angles are, but I do know they're the same, I can use x to represent those angles. So I would have x plus 126 equals 180. I can combine my x's and subtract 126 from both sides. So that would give me 2x equals how much? 54. And then we divide both sides by 2. We get 27. X equals 27 degrees. So this angle up here is 27. And this angle down here is 27. All right, we found all the angles. Let's come over here and answer these questions. We just have to identify which angle it's talking about. First one up is BCD. BCD. How big is that angle? 72 degrees. All right. Next angle is CDB. CDB. How big is that angle? 54 degrees, yes. All right. Then we have ADB. ADB. How big is that angle? 126. Then we have ABD. ABD. How big is that angle? 27 degrees. And finally, we have BAD. BAD. How big is that angle? Also 27 degrees. All right. That's where we're going to stop for today. Tomorrow you have homework due, and you also have a skills check. The first skills check of the module will be tomorrow. So first thing we will do is grade homework, answer any questions that you guys have about that homework, and then we will take your first skills check.